An investment decreases in value at a continuous rate of 5% per year. Its value in 2023 was $10,000. Write the formula in the form A of t is equal to AE to the KT for the amount A of the investment in time t years since 2023. So for this one, we're given our initial, which is our A. So we have A of t is equal to our initial, 10,000, times E to K, which is our rate. So it's 5%, but since it's decreasing, it's going to be negative 0.05 to the t. So that's how you do part A. Part B, write the formula in the form A of t is equal to AB to the t for the amount A of the investment in t years since 2023. So here we know that B is equal to E to the K because of the difference in these two formulas. We have BT and E to the K. So E to the negative 0.05 is equal to 0.9512. So A of t, in this case, for part B, is going to be equal to 10,000 times 0.9512 to the t. Last, for part C, by what percentage does the investment decrease over a 1-year period? So to do this, all we have to do is do 1 minus our rate, which gets us 0.0488, so 4.88%. That's how you do number 10. Moving on to number 11, we're going to simplify these expressions. So we have 3 log x plus 2 log y. Here, the first thing we're going to do is move our constants in front to the exponents. Now, since they're being added, we can go ahead and combine them together into multiplication. And 10 and log will cancel each other out in that way. So we have x cubed, y squared. Same thing now with part B. We have e to the 2 natural log of 4x minus 5 natural log x. Same first step. We are going to go ahead and just bring our exponents into the equation. Now we're going to be able to combine them. Here they're being subtracted, so we know that they're going to go, our x to the 5th is going to be divided. So we have 4 squared, x squared divided by x to the 5th. These will cancel out, leaving us an x cubed term on the bottom. The e and the natural log will also go away, so that'll leave us 4 squared over x cubed equal to 16 over x cubed. Moving on to number 12, we're going to start with sketching the graph of negative log 4 of x plus 2. So we need to recognize that this is going to shift us to the left 2. And it's also going to invert our graph over the x-axis. So this is going to look like, if we look right here, we can see that this is hitting around 1, 0. So ours is going to hit around negative 1, 0 because it moves over 2. Then it's going to be the opposite. So our asymptote is going to be over 2 at negative 2. And it's going to be upside down of what it was. So it's going to look something like that. Now, what are the domain and range? So our domain obviously is starting at negative 2. I'm sorry, this is going to be with a parenthesis because it never hits negative 2. But then it goes on forever to infinity. And our range is just going to be negative infinity to infinity. What is our vertical asymptote for f of x? We already went over that. It's just going to be negative 2.
Next, we're going to do 13a, and so we need to solve for x. So I have 10 to the power of 2 log base 5 over x plus 3 log base of x. The first thing I'm going to do is take those constant out in front and make those exponents. So I'm going to write this as 10 to the power of log base 10 of 5 over x squared plus log base 10 of x cubed. Okay, and now that I have addition, all of this equals 2, of course. And now I have addition happening between my logs, so I can rewrite this as multiplication inside the argument of one logarithm. So this is the same as 10 to the power of log 5 over x squared times x cubed. And this is going to be equal to 2. And then 10 to the power of log base 10, that's going to cancel each other out. So we're just left with what's inside the argument. And we have 5 over x squared times x cubed equals 2. So this is the same as 25 over x squared times x cubed equals 2. So 25x equals 2. And x equals 2 over 25. Or 0.08 if you wish. Okay, great. Okay, I think next we'll look at 13b, excuse me. And so here we have log base 2 of x plus log base 2 of x minus 7. All of that equals 3. So the first thing that I can do is I have addition happening between my logs, so I can go ahead and rewrite that as multiplication happening inside the argument of one of my logs. And I can set that equal to 3. And so I'm going to go ahead and rewrite 3 in terms of log base 2. And so how would I do that? I would say, well, log base 2 of maybe say y should equal 3. So this says that y should equal 2 to the power of 3. So log base 2 of 8 equals 3. So I can go ahead and replace that in my equation now. So I have log base 2 of x squared minus 7x. All of that equals log base 2 of 8. And so now I can go ahead and set the arguments of my logarithms equal to each other. I can just say that this is x squared minus 7x. This better equal 8. So we have x squared minus 7x minus 8 equals 0. So our two solutions should be positive 8 and negative 1. But then we check and we go to plug them back in. We can't have any negative inputs inside of our log, so this negative 1 is not going to hold. And in fact, our only answer will be this x equals 8. Okay, so now for number 14, we have a population of turtles, and we want to know how many years has passed since the turtles were initially counted after we've counted 250 turtles during one of the visits. So I'll go ahead and set the population equal to that 250, because I want to know how long it took the population to grow to that much. So I'll set up this equation, and now I just need to solve for this t, the time that it took for this to happen. So my first step, I think, is going to be to divide by 175 on both sides. Okay, and then I have 250 over 175. That's going to just equal e to the 0.045t. And how can we get rid of, how can we bring the exponent down from the e? Well, we'll go ahead and take the natural log of both sides. And then that will leave us with natural log of 250 over 175. And then we can go ahead and drop down our exponent, 0.045t times natural log of e, where, of course, the natural log of e is just 1. Okay, so now to solve for t, we just need to divide by 0.045. So t should be equal to the natural log of 250 over 175 divided by 0.045. Which should be approximately equal to 7.926 or 7.93 years. Okay, so it took 7 years for the turtle population to grow to 250 turtles. Next, we're going to look at number 15, and we have a ball being shot up vertically, and we need to find the maximum height of the ball and the time at which it reaches that maximum height. So I think first, let's go ahead and find the time at which the maximum height is reached. So to do that, I think we'll use our vertex formula. So we'll go ahead and compute negative b over 2a for our x coordinate, or our time at which this ball is at the maximum height. So here in this situation, that would be negative 24 over 2 times a negative 32, or excuse me, 2 times 16, a negative 16, which should give you a negative 32. Okay, so negative 24 over negative 32, this should work out to positive 3/4 or 0.75 seconds. Okay. All right, so now we have the time at which the maximum height was reached, and now we just need to find what the height was. So what will we do? We'll just plug in our time into our height function. So we'll find the height at 0.75 seconds. And so we'll just plug in 0.75 wherever we see a t. Plus 24 times 0.75 plus 5. And then once I do that, I should get 14 feet is the maximum height. Okay, great.
Moving on to number 16, we're going to find the formula for the polynomial shown. So we see our two zeros at -2, and I believe that looks like +4, and they both have a multiplicity of 2. So what we know is our p of x is going to be some factor of a times x plus 2 squared, because the multiplicity is 2, x minus 4 squared. Now we're going to use our known point to -24. So we're going to go ahead and plug in -24 is equal to a times 2 plus 2, so 4 squared, to -4, so -2 squared. That gets us -24 is equal to 16 times 4a, so that's going to be 64a. You'll divide by 64 to get that a is equal to -3/8. So therefore, that polynomial p of x is going to be equal to -3/8 times x plus 2 squared times x minus 4 squared. Alrighty, and moving on to number 17, section 5.5. Evaluate the limit as x approaches infinity of 3x squared minus x plus 1. So what we do here is we just have to pick the things with the highest exponent. So in this case, it's going to be the 3x squared over 2x squared, which is going to get us 3/2. That's it. So now we have for this given function, g of x is equal to 3 times x plus 8 times x minus 1 divided by, and we're going to go ahead and factor this out using ax squared plus bx plus c factoring, and that will get you x plus 8 times x minus 2. So here you can see that we can cross out our x plus 8, which gives us a whole at -8. And now we have 3 times x minus 1 divided by x minus 2. So now we need to figure out what happens as x approaches infinity. So as x approaches infinity, we know since these exponents are the same when you factor this out, they're both exponents of 1, we approach 3. So that tells us there that our horizontal asymptote is going to be 3. And our vertical asymptote is when the denominator is equal to 0, so x minus 2 equals 0. So that's going to be at x is equal to 2. Determine whether or not there are any holes. Yes, we already found that. There's a hole at 8, at -8. And then it's also going to be at the the y value that we get when we plug this in here. So we have 3 times -8 minus 1 over -8 minus 2, which gets us 2.7. So our hole is going to be at -8, 2.7. Now we're going to use what we know and draw our things. So we have our horizontal asymptote at 3. We have our vertical asymptote at 2. And we know because of the polynomial that our graph is going to look something like this, with a hole over here, right around here. And moving on to number 19, find two angles that are coterminal with -9 pi over 7, with one of those angles between 0 and 2 pi. Then name the quadrant and the reference angle for -9 pi over 7. So to find two coterminal angles, all we have to do is we have to add 2 pi and we have to subtract 2 pi. So then we also have -9 pi over 7 minus 2 pi. So to do this, we're just going to multiply these by 7 over 7 to get a common denominator. So 9 pi plus 14 pi over 7 is going to get us positive 5 pi over 7, which satisfies our first requirement. It's between 0 and 2 pi. Then when we subtract 14, we're going to get negative 23 over 7 pi over 7. So those are our two coterminal angles. Now we have this negative 9 pi over 7 angle, which we know goes a little bit farther than 1 pi in the negative direction, so it's around here. And our reference angle is going to be this little angle right here. This is our reference angle from the x-axis. So we know that this is in quadrant 2. And this little reference angle is going to be 2 pi over 7. And we know that because we know that this whole thing here, this guy, is 2 pi minus our 9 pi over 7, which gets us 5 pi over 7. And this whole thing is equal to pi. So therefore, if we do pi minus 5 pi over 7, we get 2 pi over 7, which is our reference angle. So this next one's just going to be big on the unit circle here. Find 4 different angles so that the sine of the angle is equal to 1 over root 2. Hypothetically, if you were to multiply this by root 2 over root 2, you would get that that's equal to root 2 over 2. Using our unit circle, we know this happens in 2 places. Sorry, those were terrible lines. Let me see if I can do better. Okay, I can't do better, so that's what you get. So we know this first angle here is going to be at pi over 4, and that's just using our unit circle. And this next one's going to be plus 90 degrees from there. So that gives it to us at 3 pi over 4. So we found 2 of our angles. Now to find the other ones, we can just subtract 2 pi from the other 2. So pi over 4 minus 2 pi, which is going to be negative 7 pi over 4. And then 3 pi over 4 minus 2 pi is going to get us negative 5 pi over 4. And the reason it doesn't work to just use these angles down here is because these are both negative root 2 over 2. And it asks for the positive root 2 over 2. So that's the answer to the first one, is negative 5 pi over 4, negative 7 pi over 4, and 3 pi over 4, and pi over 4. And same thing for the next one, but we want root 3 over 2. So we know that that happens with the cosine when the x value of the unit circle is equal to root 3 over 2. So that happens at pi over 6. And then our cosine over in this quadrant is negative. Same within this quadrant. So we have to go all the way over here where we get that that is 11 pi over 6. So now, to get our other angles, all we can do is just use the negatives of these ones, because if we go at it from the other way, we're still going to get those angles. So my 2 other angles are going to be negative 11 pi over 6 and negative pi over 6. So that's the 4 angles there. All right, number 22, Cassie measures the angle of elevation from the ground to the top of the pyramid to be 28 degrees. If the pyramid is 300 feet tall and the angle of elevation of its sides is 40 degrees, how far away from the pyramid's base is Cassie standing? So the first thing we need to do is we need to figure out what this line right here is in order to look at our bigger triangle. So to figure out that triangle, we know that tan of 40 is opposite over adjacent. So this is 300 over our adjacent value, which I can call y, which is what we're solving for here. That gets us that y is equal to 300 divided by tan 40 degrees, which gets us 350.5 feet. Oh, sorry, 357.5. I read my calculator wrong. Next, we need to find this whole bottom here, so let's call this L. And we know that the tangent of 28 is equal to 300 divided by L, because this whole thing is one big triangle. So that gets us that L is equal to 564.217 feet. We're solving for this little value x, so x is equal to L minus y, which is equal to 564.2 minus 357.5, which gets us about 207 feet. And moving on to number 23. In order to solve this, we first need to make sure our x term in here is alone. So we're going to have to factor out that 2 because we want our x term to be all by itself. So 2 times x minus pi over 8 plus 3. And now we have it in a form we're used to. So we have that our amplitude is the square root of a. Remember that we have y is equal to a times sine of our b times x minus h plus k. So a is our amplitude. The absolute value of it here is 5. Our period is going to be 2 pi over b. So 2 pi over 2. So that's going to get us pi. Our phase shift is going to be pi over 8, and it's positive because it's the opposite of what it says, so to the right. And our vertical shift is going to be 3 up.